Welcome to the shop. I'm still making parts for NQALHA Production Run 4, 750 parts. Little bit by little bit, I'm getting them done, not taking a break, so time to get going. This part is a rather simple part. I've pretty much finished all of the complex parts, and the parts will start getting a little simpler as the project proceeds. I'm going to be experimenting with a slightly different tool path. I'm going to be plunging a roughing cutter into 3/8 6061 aluminum and cutting out a 49 millimeter hole in the material, and I'm trying to reduce or eliminate the buildup of rat's nest on the end of the cutter by using either plunge or ramp cycle instead of just feeding directly down in one continuous feed. So I slightly changed the PEC parameters to try to see if I can reduce the amount of buildup on the cutter. As in previous recent videos, machine is set up. I've used the Heimer indicator to set the X and Y zeros. I've used the electronic tool setter to set the Z zeros. Got the tools loaded in the tool changer. It's a very simple operation. The first operation is very simple, and the only thing that I'm really changing here from the previous time that I ran it is trying to make the cutter stay a little cleaner. So let's find out if it actually works as I expect, or is there a chance that it might get worse? Single block mode. Pre-feed looks good. Feed looks good. Here we go. Well, guess what? That's not the tool path I just programmed. Back to the CAD room. Yep. So many ways to make small mistakes. Just because I'm curious, I'm going to take this guy out. There's a finish operation coming up next, but I'm just curious to see if it works, so I'll do the finish off camera. And go ahead and see. This is what I'm trying to eliminate. I'm not sure it matters, but still, trying to eliminate it. Boy, it was looking good there on the first pass. That PEC actually looked like it was doing the job. Okay. I'm gonna run the finish pass. Finger on the stop button. So, I'm going to do a quick sanity check here. This fixture plug that you can probably see should fit, oh yeah, like a nice smooth slip fit. Looks like the parts are coming out correctly. I may or may not continue to experiment with different strategies to try to keep that cutter clean, but I'll turn the camera off, and when I come back for the next operation, I'll kind of, well, actually, hey, why not? Let's go ahead and show the second operation right now. I'm gonna combine the two operations into a combo toolpath that executes both of them with one part load and one kind of blowing off the chips and coolant cycle. But for now, might as well just really quickly put a little deburr on this guy. And just verify that, verify that the second operation is going to work correctly. I'm using a half-inch 13 socket screw with an aluminum washer and a special machined alignment plug. I also noticed that, well, the part does rotate, so it's going to require a little bit of not very critical eyebolic and fingular alignment, which shouldn't be a problem, and the part is intentionally oversized, and so a fraction of a degree of error don't make no difference at all. So okay, 0 on the top of the tooling plate, returning to the roughing cutter. That is not correct. So it's back to the CAD room. Just so you understand what this was all about, when I'm in production, I'm typically using work offset 1 and work offset 3. Sometimes for prototyping, when I don't want to go through the extra trouble of indicating the left vise, I'll run both first and second operation on work offset 1, and I must have been doing some development on this because the toolpath was set for work offset 1. So let's try this again. Work offset 3, single block, stopping in a same position. The aluminum shredder, 3-flute, aluminum roughing cutter with serrated flutes from Lakeshore Carbide. 3 passes through 3/8 aluminum, 5,140 RPM, 40 inches per minute. And as I've said before, the Tormach doesn't have the rigidity, the horsepower, or more importantly, doesn't hold the tool well enough to really push it any further than this. I can be a lot more aggressive on the Bridgeport. So there we have roughing pass looking really good. Gonna switch over. This is a very simple second operation as well. Gonna switch over to the next operation. Single block. Make sure it starts in the right place. 5,140 RPM, taking a 15 thousandths finish pass. And this profile is fairly critical. I'm actually using cutter diameter compensation because this part needs to fit. This part forms the hinge on the twist axis magnet. So I'm going to go over to my pile of finished parts, do a quick sanity check, and sure enough, in the camera view, that is just about perfect. You almost can't see the gap. It's designed to just have, I don't know, a thousandth or so of gap, because I don't want a big loose gap to have the thing flopping around side to side. I want the gap to be almost imperceptible, but not so tight that it causes binding. Because obviously if it was a zero gap, then I'd get binding aplenty. So that's it for first and second operation. I'm going to go back to the CAD room and see if I can tweak up that first operation toolpath a tiny bit, see if I can reduce a bit of that rat nest buildup on the cutter, and if not, I'll just keep going, keep making parts, because other than flinging the coolant around, I don't think the rat nest really hurts anything, but I'd really love to get rid of it. So see you later for the third and fourth operation on this part. So I changed my mind again. After a slight modification to the PEC cycle, I believe I've achieved a clean roughing cutter. So hopefully it'll work twice in a row. So now I'm going to show the combo tool path with, hopefully, with any luck, we'll have a clean roughing cutter coming out at the end. So let's see how repeatable it is. Worked perfectly first time. Well, okie dokie. Let me load the right toolpath this time. So many ways to make simple mistakes. It cleared itself, the cutter came out clean, but there was, on the second level, I did see some buildup that kind of flying coolant on me and got coolant dots on my safety glasses. I built this splash guard. It's a custom-made thing that the Tormach sells a full enclosure kit. I don't like a full enclosure. I like to have visibility, but it's always a trade-off that For most milling operations, the splash guard keeps the coolant under control, but in some cases, especially with buildup on the end of the cutter, I get coolant all over the place. So now moving to the second part of the combo operation, work offset 3, finger on the stop button just in case. Everything looks fine. The third operation is going to be drilling some holes, and then the fourth operation will be to cut a slot, because this is a clamping fixture that needs to have a tiny counterbore, a through hole, a cap drill hole, a cap, and a slot for a 1032 screw, so that there's a little bit of flex to grip the 49mm electromagnet. All is well. I think I'm just going to run the batch and stop dicking with it. All of the first and second operations have been completed, and there's the part. So now I'm going to put in, I put the medium tall jaws in and indicated them with the Heimer indicator. Z0 is still on the vise surface, and X and Y0 at the back corner. Got a little spacer here, kind of like get the guy off the vise surface just a little bit, makes it easier to put it in and out, and gives a bit extra clearance for the drill as it pokes through the other end. So this operation, going to be drilling a hole perpendicular, drilling and reaming a hole perpendicular. This hole is a fairly critical hole. This is the hole for the axle, because this guy, the design of this is that this is a hinge, so that when the magnet is de-energized, it doesn't drag against the plate. And so it's supposed to have a little bit of motion, but not very much. It's supposed to just have a few thousandths of motion, and so the axle hole needs to be drilled and reamed fairly accurately. So in order to get sufficient clearance with the collet nut, I have to use a fairly long drill bit, and as I've said numerous times in the past, stick out is a problem when trying to accurately locate a hole. So I'm using the same scheme that I've used before, which is to rapid down to the surface of the part, very slowly feed at a ½ inch per minute, and just touch and form a tiny little divot, and then start the regular peck cycle. I'm also going to counterbore, clearance drill, and tap drill this side, and then the fourth operation will be to cut a slot to make this into a kind of a little clamp. So align very carefully with the side of the vise, making sure that the stop is clean and clear of chips. And going to be running it like all these programs. This is a known trusted toolpath, more or less. Now that probably a leftover. It's not correct, but it probably isn't wrong either. Yeah, the pre-feed depth that Bobcad puts in, sometimes it gets confused. It is now in the right place, and it's feeding down and making my little divot. And now, I'm going to go ahead and do a full peck cycle. 4,000 RPM, 10 inches per minute. I forget what the peck is, 80 thousandths per peck. This is a, what is it? It's the one size under quarter inch, 1/64 under quarter inch. And then the reamer will be a nominal quarter inch reamer. So, hole has been drilled successfully. Get Mr. Reamer in place. Okay. Successful ream. Next will be a very slight counterbore, just barely kissing the surface. And the purpose of that is that the part was cut with a 3/8 bit, and if I didn't give it that little bit of counterbore, the socket screw would end up hitting the inside corner of the radius. Now that, yeah, that really wasn't right. That really wasn't right. I didn't get any kiss at all. So let me go back to the CAD room, check the program. Toolpath actually looks correct. Checking the numbers here, so what else could it be? Recheck the tool lengths. It's only a few thousandths difference in tool length. I've got me a mystery here. Just do a quick sanity check here. And yeah, I don't really like that. So I'm going to turn the cameras off and investigate a little further. There's at least 2 or 3 things here that I'm not happy about. So that was a bit of a mystery that took way longer than I thought to figure out. I was just staring at it and going, no, this can't be right. This can't be right. And it turns out that it's, there's actually an interesting lesson to be learned here. The design of this particular part has evolved over time, and it's a relatively new design. It was introduced on version 2.2, and I did make 10 of them, and they were successful, and the units are out there, and they're working fine. But during the development, different versions ended up getting saved with similar or the same file names, and it ends up that the version I was working on today, it had a slight error because one of its important dimensions was kind of left over from a previous version that I was using during development. So, and it wasn't much of an error, but it was enough that I wanted to stop and, hey, this isn't right. So, all appears to be well. I think I'm back on target again. I think I can restart the process, and revision control can make you crazy, especially during prototype development, especially with Cad systems. That's the one kind of downside. I mean, I love Cad systems. I used to, when I started my engineering career, I had a drafting board and designed with pencils, and boy, I was so happy to get my first Cad system. But the downside of Cad systems is that during prototype development, you can have an idea, make a drawing, decide, no, that idea sucks, make another one, make another one, make another one, make a lot of small tweaks, little adjustments, move this around, move that around, move this around, move that around, and then end up with your project directory littered with obsolete, ancient, wrong, old drawings. And if they look almost exactly the same as the correct one, that's when the fun begins. So I am very confident that the problem has been solved, but you never know. You never know until you run it. So here we go. I checked everything. I rechecked all of the zeros, rechecked the tool length. And let me, while I'm talking, I'm too fast on the trigger finger. Yeah, I rechecked everything. Re-zeroed the z-axis, re-referenced the z-axis, re-zeroed the z, rechecked the tool lengths, and it turns out the problem was in the CAD design. Of course, I rechecked the tool path, and the tool path was being generated correctly based on the bogus CAD design. So, revision control. One of the most difficult manual operations to perform is, after prototype development is concluded, to clean up all of the old, incorrect preliminary designs that you have laying around, because I hate doing things manually. I prefer when the computer can do them for me, because computers make less mistakes than I do. So let's see if this is right. But cleaning up and removing all of the obsolete old preliminary versions during prototype development. Have to do it by hand. Yes, perfect. Exactly as designed. So we're back in action. And I think that the stopping at the wrong preliminary pre-feed position, it's supposed to be about an inch above the feed position, and now it looks like it's, I don't know, 2 inches or so. That's probably also a leftover of one of the obsolete versions that was created during development. And yes, the collet nut did clear. I was watching that very carefully. So one more hole. This is the tap drill hole, and I can't power tap this part because of the clearance problem that the collet nut of the tap holder would hit the part. So I have to tap this one by hand, and fortunately it's the perfect job for accurate hand tapping, because before I cut the slot I have the clearance hole and the tap drill hole precisely aligned in the same machining operation, so it's pretty much guaranteed that my hand tap is going to be straight. And even if the hand tap wasn't perfectly straight, this one, no, take that back. This one does need to be straight. So I was going to say it doesn't matter, but then I thought about it for a moment. It does matter. So hand tapping. Then, the final operation here, I'm going to go over to the bridge port and grab a parallel. I don't have my nice drilled stops on the bridge port, so I end up using this clamp method, and it does work. There's nothing wrong with it. It does work, but so, going to be, oh, that's annoying. Going to be using the slitting saw, and I actually feed this guy by hand, but I do use the DRO to set the height. So just touch off, DRO to 0, go down, actually gotta raise the knee a little bit. Even the simple parts take time. I thought this one would go faster. Okay, so check the setup sheet one more time. Just verify that, verify the distance here. Everything looks right. I turn the spindle off right as the cutter is breaking through, because once the slot has been cut, the upper piece is not very stable. So there's the part. There's the side view showing that pesky little counter bore. Everything's looking good. I'm going to go ahead and run the rest of the batch, toss them in the vibratory finisher, and that's it for today. Thanks for watching. It's been fun. And a tiny bit annoying.